Okay, so what we've talked about so far is finding the discriminant. And we use the discriminant to understand what our roots were going to be, right? So if you guys remember, the discriminant is related as b squared minus 4 times a times c. All right, now we worked on some problems up here. And I want to kind of explain why you can use the discriminant and what it's going to be as part of our problem. So remember, when we had a negative discriminant, we had a complex solution. When we had a discriminant that was not a square number, it became an irrational. We had two irrational roots. And when you had your discriminant equal to 0, that meant you had one real root. And when you had your discriminant being positive but also being a square number, you had two rational roots. Now, why does that work? And how do you know that? Why does that rule kind of exist? Well, because the discriminant is going to be part of our quadratic formula. All right? I'm not going to go through where we bring up the quadratic formula. I'll just provide you the simple equation. So what you'll notice, ladies and gentlemen, is the discriminant is actually going to be what we call the discriminant of a. The discriminant is always what's under your square root. So that's why we call it the discriminant, because it's what you're taking the square root of. So does it make sense now? If this is negative, when you take the square root of a negative number, what are you going to have? Your complex imaginary number, right? Right? If you take the square root of a non-square number, you can't simplify it any further, right? The square root of 2 is the square root of 2. You can't simplify it. It's irrational. If you have 0, well, you're not going to have a plus or minus 0. If I take the square root of 0, it's 0. There is no plus or minus 0. And then if you have the square root of like 25, you can see it's plus or minus 5, which is an integer. So when you have square numbers, you're going to have integers. So that's why when I'm completing the quadratic formula, I always like to find the discriminant first. One, it tells me what my roots are going to be, and then also it tells me the description of my roots. If I'm going to have complex, 2 real, 1 real, or 2 imaginary, and then also it's part of actually solving. So the rest of the equation just goes like this: plus or minus b squared all over 2a. Now, what does this equal? This, opposite of b plus or minus, thank you, b squared. There you go. Everything is divided by 2a. Now, what exactly does this equal? Well, when you're doing the quadratic formula, what does this equal? This is going to equal your roots, your solutions, your x-intercepts. So you can say x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So ladies and gentlemen, what we did is we found the discriminant already, correct? We already found the discriminant for each one of these problems. So what I'd like you guys to do is now use your discriminant under the square root and see if you can find the remaining answers for that, okay?